Hello to everyone, and in today's video we are going to be looking at solving differential equation using separating variables. So the first example that we have above here is a differential equation dy over dx equals to 2 sine x plus 3 cos x. So we want to solve this differential equation by separating variables, and we know to solve our differential equation we need to put in the form y equal to f of x. So basically this is what we're trying to do. So now looking at what we have been given above here, if we want to solve this, then the first step that we need to do is we multiply all through by dy by dx. So we have dy to be equal to 2 sine x plus 3 cos x. Now since we'll multiply all through by dx, then the dx is going to come here. Now if we look at our left hand side, the function is in terms of our derivative is in terms of y, and if we look at our right hand side, our derivative in terms of x. So here we have separated our variables. Now to solve this, we take now our integral sign on both sides. So if we take our integral sign on both sides, then the integral of dy is going to give us y. Now this is a constant, 2 is a constant, so it can be factored out of the integral sign. So here we're going to have 2. Now the integral of sine x is minus cos x, so the minus is there, so it should be minus cos x. The same thing with 3, so 3 can be factored out, plus 3, and the integral of cos x is sine x plus a constant k, the constant of integration. So basically that is the solution. That is our solution of the integral. That is the solution of our integral. Now on to the second question. Okay, now here's our second question, and to solve this we have been given our integral x 2y dy over dx equals to minus x. So to separate our variables, we simply send x the other way. So if we send x this way, then we're going to have on the right hand side, we are going to have, on the left hand side we are going to have 2y dy all over dx equal to minus x. So when x goes this way, it becomes minus x, so minus x. So we're going to have 2y dy all over dx equal to minus 2x. Now looking at this, if we divide all through by 2, we're going to have our y dy all over dx to give us minus x. Multiplying all through by dx, we're going to have our y dy to be equals to minus x dx. So we see here that we have clearly separated our variable, because our function in the left hand side is all in terms of y, and our function in the right hand side is all in terms of x. So from there we take our integral sign. So if we take our integral sign, we're going to have the integral of y dy times the integral of x dx. So if we do that, when we integrate y, we're going to have y squared all over 2 equal to the integral of x is since there's a minus sign, we maintain a minus, it will be x squared all over 2 and plus the constant of integration k. Now for those who do not know yet, if we have a function, let's say y equals to a x raised to the power n, then the integral of y should give us a x raised to the power n plus 1 divided by n plus 1. So this is the general formula. Now here we want our function to be in the form y equal to f of x, right? So we're going to have y squared now will be equal to, if we multiply through by 2, we're going to have minus x squared plus 2k plus 2k. Now taking the square root on both sides, we're going to have y to be equal to the square root of minus x squared plus 2k. We can call it t since k is a constant and 2 is a constant. So a product of two constants will simply give us a constant. So here we can simply say k, where you can maybe just say, if you want, we can add a text there. Where t is equals to 2k. You just put your work for your work to look nice, just for the work to look presentable. Yeah, so that's our function. Now if we look at this one here, if we look at this function here, this function here looks like an equation of an ellipse. So this is the general formula, or an equation of an ellipse, because from here, if we send our x that way on the left hand side, if we send our function here, so this will imply that y squared divided by 2 plus x squared divided by 2 equal to k. So this is clearly our equation of an ellipse. This is the equation of an ellipse. So that was just a remark. Now going on to the third. Okay, now this is our question 3. We have to solve this. Now to solve this question, we have to separate our variables. So the first thing we might look at is, first of all, we see that on the left hand side we have our function in terms of y and x. So if we want our left hand side to contain just y, then we have to multiply all through by dx. So if we multiply all through by dx, we are going to have dy all over y times dx divided by dx equal to 2 all over x times dx. So clearly this will cancel this, so we're left with dy all over y to be equals to 2 dx all over x. So here we have separated our variables because on the left hand side our function is all in terms of y, and on the right hand side our function is in terms of x. So if we take our integral sign on both sides of the differential equation, the integral of 1 on y, because this can be written as the integral of 1 all over y dy to be equals to 2 the integral of 1 all over x dx. So if we continue here above here, we are going to have the integral of 1 on y is ln y. So this will be equal to, the integral of this will be 2 ln x, so plus our constant of integration k. So this is our solution. But since we want our function to be since we want our solution to be in the form y equals to fx, then we're going to take anti-logarithm on both sides. So here simply will be e raised to the power the ln of y, which will be equals to e raised to the power 2 ln x plus k. So here we have our y, which will be equals to, here we can write this as e raised to the power the ln of x squared now plus k. So here we are going to have our y to be equals to x squared. We are going to have x squared times our e raised to the power k. Now this is actually a trick, because most of the time students will write y equals to x squared plus e to the power k, but that's not the case, because from the law of logarithm, if we have e raised to the power a times e raised to the power b, then this can simply be written as e raised to the power a plus b. So this is clear and is similar to this. That is why here I take a product. Now k is a constant, e is a constant, so all of this can be written as a constant. Therefore, our final solution will actually be y equals to k, a constant k, or our constant can be any constant t. Let's say t. Let's say t x squared. So that is it, and this is clearly a quadratic function. Okay guys, that's all about the part 1 of differential equations. Many more parts will be coming using homogeneous equation, the Bernoulli equation, second order differential equation. All of those methods will be parts will be coming in subsequent videos. So for those interested in getting those videos, you can simply subscribe to my channel. You like this video, so that whenever I upload new videos, you'll be notified. So please also feel free to put in the comment section your questions, where you're watching from. You can maybe mention your school, and that will help in the YouTube algorithm. So see you guys in the next video.